Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve October-November 2023 1-2 paper. This is a multiple choice paper, and we also call this paper 1. And the time allowed for this paper is 1 hour. So let's start today's paper. So in front of you, that paper we have is October-November 2023 1-2 paper. So let's start. And here we go. The first question is showing up on your screen. So it says the diagram shows the level of liquid in a measuring cylinder. The scale is marked in centimeter cube. What is the volume of the liquid? The volume is, we will take the lower meniscus, and it is 21, 22, 23, 24. So it is 24.0, you can say, centimeter cube. 24. So let's take this. So I think B is the answer. So let's check. So B is the right answer. The next question. Okay. Question number 2. The diagram shows the distance time graph of a car. The car is traveling along a straight road up a hill. Which quantity for the car is constant and greater than 0? You can see here, this is a speed time graph, and sorry, it's a distance time graph. The gradient of the distance time graph represents the velocity. And because the gradient is constant, so it means that the gradient is constant. The gradient is constant, that means the speed is constant. Which quantity for the car is constant and greater than 0? So the speed is constant, that means that the kinetic energy depends upon the speeds and velocity, you can say. The kinetic energy formula is 1 by 2 mv square. So if the velocity or the speed of our body is constant, then it means its kinetic energy is also constant. So which quantity for the car is constant and greater than 0? Acceleration, no. Displacement, acceleration is constant, but because when the velocity is constant, the acceleration is 0. But here it says it should be greater than 0. That's why acceleration is not the answer. Displacement is changing, gravitational potential energy, that is because that is moving. The car is traveling a straight road up a hill. Okay. So because it's moving up a hill, so its gravitational potential energy is increasing. Kinetic energy is 100% constant. I think D is the right answer, sir. Question number 2, D is the right answer. We have question number 3. A distance time graph and a speed time graph show the motion of an object. How are the speed and the acceleration of the object determined from these graphs? So if you have distance time graph, from the gradient of the distance time graph, you can tell the speed. And in the case of the speed time graph, from the gradient of the speed time graph, you can tell the acceleration. So speed is the gradient of the distance time graph, and the acceleration is the gradient of the speed time graph. So I think D looks the perfect answer. So question number 3, D looks the good answer. And let's check. Let's check question number 3. D is the right answer, sir. Question number 4. A student finds that the mass of a rock is 65 grams. She pours 30 centimeter cube of water into a measuring cylinder. She places the rock in the water so that the water covers the rock completely. the water level rises to 55 centimeter cube. What is the density of the rock? You know, the mass of the rock is given, that 65 gram. We can find the volume of the rock from this measuring cylinder's readings. V2 is 55 centimeter cube and the rock is in the water. And when there is no rock, the volume of the water is 30 centimeter cube. So if you subtract from V2 the V1, that is 30 centimeter cube, 55 minus 30, and you will get the volume of the rock. Once you know the volume, then you can find out the density. Density is mass divided by volume. So the volume of the rock is final volume minus initial volume, 55 minus 30, that is 25 centimeter cube. Density is mass divided by volume, so it will be 65 gram divided by 25 centimeter cube. So my answer will be 2.6 grams per centimeter cube. 2.6 grams per centimeter cube. 2.6 grams per centimeter cube. So I think D is the right answer. Question number 4, D is the right answer, sir. Okay, so we have question number 5. A small submarine of mass 1000 kg sinks in water with a constant speed of 2.0 meter per second. So there is a submarine which is going down in the water. What is the resultant force exerted on the submarine as it sinks? So here we have that it's going with the constant speed. When something is going down with a constant speed, the resultant force acting on it is zero. The forces are balanced. So I think what is the resultant force exerted on the submarine as it sinks? It must be zero. I think A is the choice. Question number 5, A is the right choice, sir. Question number 6. A student drops from rest a light ball in air. The ball experiences some air resistance as it falls. What happens to the velocity and to the acceleration of the ball during the first few seconds after the release? You see, as you drop the ball, as it is going down, its velocity increases. So velocity is increasing. When it starts falling downward, at the start there is no air resistance, so the downward force acting on it is only the weight. There is no upward force because the ball is not moving downward. There is no air resistance. So at the start the resultant force is maximum, so the acceleration downward is also maximum. But as it moves, because its velocity increases, so the air resistance acting on it also increases. Due to this, what happens? The resultant force, as the acceleration increases, because the weight remains the same, the resultant force decreases, so the acceleration decreases. And after some time, it's possible that the acceleration might become zero when the air resistance and the weight, they will become equal to each other. Resultant force will be zero. So as it starts falling down, the velocity increases, but at the start, the acceleration is maximum, and then the acceleration gradually decreases. So the velocity increases, but the acceleration will decrease, I think. So question number 6, I think C should be the choice. The velocity should increase and the acceleration should decrease. Let's check. Question number 6, C is the right answer, sir. Question number 7 is showing up on your screen. The stopping distance of a car traveling at a certain speed is measured in 4 different situations. On a dry road with new tires. On a dry road with old worn tires. On a wet road with new tires. On a wet road with old worn tires. The results are shown. So stopping distance for W, the stopping distance W situation is 12. For X situation, it's 16. For Y, it is 17. And for Z, it is 40. Which two results are possible measurements on the dry road with the old tires? Okay. So when on the dry road with the new tires, the distance must be minimum. So in that case, if I think the distance is minimum, so in that case, where will be the minimum distance? Where is the minimum distance? So this is the minimum distance, and that must be with the dry road and new tires. Okay, but we are looking for which situation? Dry road with the old tires. Okay, now, so the maximum distance covered in the distance, brake stopping distance will be maximum when the conditions will be wet and the tires will be old. So wet and wet road with the old worn tires, that will have maximum distance covered, and that will be this one. So the remaining two options are these two. So their option is the dry road with the old tires, because the road is dry and you have old and worn tires. What is the other situation? This situation is with this. Okay. So this is that situation, and this is this situation. I am looking for dry road with the old tires. Okay. A wet road with the new tires, because of the new tires, the on the dry road, on a dry road with the old tires, it should cover, because the old tire is a more bigger factor. Okay. So I think Y should be the answer. I think the Y looks, but here is a which two results are possible minimum to dry road with the old tire. So we have these two options. Okay. So X and Y, X and Y, X and Y, X and Y. Where is that? Okay. So this is my answer. Because he gave us the opportunity to choose, to have two choices. So X and Y, out of these two, the answer can be. So B is the choice. If we have to choose one, then it would have been very difficult. So I think B is the choice. Question number 7, B is the choice. This question is a little bit difficult. It's a brand new question. Okay. Here we have question number 8. He says, a spring has a length of 9 centimeter when loaded with 200-gram mass. The extension mass graph for the spring is shown. The 200-gram mass is replaced with the 100-gram mass. What is the new length of the spring? Okay. So you see, here we have the extension, and when there is 200 gram, so a spring has a length of 9 centimeters when loaded between the extension time graph is. So extension will basically become, you see, at 200, what is the extension? The extension is 2 centimeter. What is the length here? 9 centimeter. So from 9 centimeter, you subtract the extension, you will get the unstretched length, and that will be 7 centimeter. At 200, at 100, the extension is how much? 1 centimeter. So unstretched length is 7. So add 1 in it, and that will give you 8. So I think B is the answer. Question number 8, B is the answer. Let me show you if I have done. No, we have not done the working on it. Question number 8, B is the choice. Okay, let me show you the working, how this is done. So L naught will be equals to L, the stretch length, minus the extension. Okay. So from 9, I subtract 2. So I will get 7. And then at 100 gram, the extension is 1 centimeter. So 7 plus 1, that will give you 8. I hope you understand. So here we have question number 9. He said the International Space Station orbits the Earth. Which arrow shows the direction of the force on the International Space Station when it is at the point X? You see, because that space station is moving in circular path, so the direction of the force is always towards the center of that circle. So this is that circle. So the center of the circle will be here. So the direction of the force must be towards the center of the circle. So I think question number 9A is the choice. And that is true. Okay, so here we have question number 10. He says, which experiment is equals to impulse? You know, impulse is change in momentum. Or you can say the impulse is force multiply time. Okay, this is called impulse. So change in momentum divided by time, no, that is force. Change in momentum, yes, this is the answer. And force multiplied distance movement, no, that's work done. And force divided by area, that is something I don't know. And so that means B is the choice. Question number 10, B is the right answer, sir. Then we have question number 11, and it says, question number 11, and it says, yeah. A box with mass 4 kg is pulled from rest along a horizontal floor by a constant force F. A constant frictional force of 1 Newton acts on the box. When the box has traveled 1 meter, its velocity is 1.5 meter per second. The kinetic energy of the box is equal to the work done on the box. What is the force F? Okay, so the mass of the box is 4 kg. The frictional force is 1 Newton. The box has moved 1 meter and it has gained how much velocity? 1.5 meter per second. It was at rest, and now after so after some time, after covering 1 meter, it has 1.5 meter per second speed. The kinetic energy of the box is equal to the work done. Kinetic energy is 1 by 2 mv square. Work done is force multiplied the distance. The force, okay, this is question number 11. So here we have, so here we are. The kinetic energy is 1 by 2 mv square. So at the end, the kinetic energy is 1 by 2 into 4 into 1.5 square. So that will be 4.5 joules. So because the work done is equals to the kinetic energy, he said. So the work done is also equals to the force multiplied distance. So the force is, so 1.5 joule is equals to the F multiplied 1 because it covered a distance of 1 meter. So the F will be equals to 4.5 Newton. The force which you will have to apply, that must overcome the friction plus that must also provide this resultant force. So the force which you apply will be 4.5 plus 1. So you have to give the resultant force plus you have to overcome the friction. So 4.5 plus 1, so 5.5 Newton. So the force which you will apply, that is, here you can see what is that F. A box with a mass pulled from rest along horizontal floor by a constant force F. Okay. So the F will be how much? 5.5. So it will be 5.5 Newton. Question number 11, D is the answer, sir. Question number 12. The diagram shows a curved track. A ball is released from the position shown. At which point is the gravitational potential energy stored in the ball the maximum? You know the gravitational potential energy depends upon the formula for that is mgh. So it depends upon the mass and the gravitational field strength, and it also depends upon the height from the ground. So the maximum height from the floor or the ground from the table, which point has the maximum height? I think that is A, because their question is, at which point is the gravitational energy stored in the ball maximum? So that will be at point A. Question number 12A is the answer, sir. Question number 13. How does an oil-fired power station differs from a nuclear power station? You see, in an oil power station, you are using, these fossil fuels. And when you burn fossil fuels, obviously some greenhouse gases are given out, so which causes the pollution in the atmosphere. And in the case of the nuclear power station, no greenhouse gases are given out. So, so one difference is this, and it says gas emitted by the hot fuel are emitted into the atmosphere. That is true. Steam is produced in a boiler using the hot fuel. The steam is produced in both nuclear reactor and in the oil powered station. The hot steam is used to turn a turbine. This is method used in both the cases. Turbines are used to drive an electric generator that is also used in both the power stations. So the only difference remain is the A choice where it says gases emitted by hot fuel are emitted into the atmosphere. So that is the main difference. Question number 13A is the choice. So here we have question number 4. Here we have question number. Okay, so we have to decrease the size. An electric motor is used to lift a load at a constant speed. So here we have an electric motor, so it's lifting a load vertically upward. The gravitational potential energy stored in the load increases. The moving load also has stored kinetic energy. Which expression is used to calculate the efficiency of the motor when the load is being lifted at a constant rate? You see, the efficiency will be so the formula for the efficiency is basically the useful output energy divided by the input energy multiply 100, or it can be useful output power divided by the total input power multiply 100. In case you can have multiply 100, or you can ignore it, multiply 100. Okay. So the useful thing which is happening here is the load is getting gravitational potential energy. Okay. So that is the useful power. Gravitational potential energy gained per second is the useful power. And the power supplied to the electric motor, that is the input power. So I think B looks the best answer. C and D are totally wrong. Power supplied, they have written in the numerator, that is wrong. So actual choice is B. Gravitational potential energy gained per second, that is the useful output power, and divided by the power supply, that is the total input power. So I think B is the best option. Question number 14, B is the option, sir. And this is a little tricky question. Okay, so we are going to the next question. That is question number 15. A battery delivers 3000 joules of energy to a small 2-watt electric motor before the battery stops working. For how long is the motor switched on? So we have the power here, we have the energy here, and the time is question. You know the power is equals to the energy divided by time. So from that formula, we can calculate the time. So the power is equals to energy divided by time. The power is 2 and the time is question. Energy is 3000. So 2 equals to 3000 divided by time. So time will be equals to 3000 divided by 2. And so 2, because here it will be 3000 divided by, let me check. Let me check. So because the power is equals to energy divided by time, so energy is 2 watts. Sorry, the power is 2 watts. The energy is 3000 joules, and the time is question. So the time will be 3000 divided by 2, and that the time will be 1500 seconds. So then we will convert the 1500 seconds into minutes. For that, I will divide the 1500 with the 60, and it will give me 25 minutes. So the final answer is 25 minutes. So let's check here. 25 minutes is the D choice. Question number 15, D choice. My internet is again and again interrupting, so due to that, there is some little problem. Question number 16. A man finds it difficult to hammer a wooden post into the ground. How could he make the post go into more easily? You see, if the wooden post, if you want it to uh, use hammer to put that into the ground, that end of the wooden post must be pointed. The contact area of that end with the ground should be minimum. Then what will happen? The pressure will become maximum. Okay, so make the bottom of the post pointed, that is true. Make the top of the post pointed, no, that will not work. Use a longer post, no. Use a wider post, no. So A is the best answer. The bottom of the post must be pointed like the nail. So question number 16, A choice. Question number 16, A is the right choice, sir. Question number 17 is in front of you. He says, we have to reduce the size. Okay. So here we have. He says, which diagram shows the names of the changes of state that correspond to the directions of the arrows? So in the freezing, the liquid converts into solid. In the freezing, the liquid converts into solid. And in the melting, the solid converts into the liquid. In the evaporation, the liquid converts into gas, and in the condensing, the gas converts into the liquid. I think D is the right. The rest of the answers are wrong. 17, D is the right choice, sir. D is the right choice. This question is about the conversion of the states. Okay, question number 18. It says, a sealed cylinder containing gas is left in direct sunlight. Oh, when the cylinder is sealed, it means its volume will not change. Eventually, the cylinder explodes. How is this explained in terms of the behavior of the gas particles? Because the volume is constant, when the temperature will rise, the molecules will collide more frequently, they will exert more force on the walls of the cylinder, and the pressure of the gas inside the cylinder will increase, and that will cause the explosion. Each particle gets bigger and they collide with each other more often. No, the particle do not get bigger, or the particles do not expand, you can say. Each particle gets bigger and they collide harder with the cylinder. Particles do not get bigger. The particles gain kinetic energy and hit the cylinder harder and more often. Yes, this is the exact explanation. The particles gain kinetic energy and hit the cylinder harder and more often. Yes, that's true. I think C is the choice. The particles lose kinetic energy and they hit the. No, they do not lose the kinetic energy. The temperature is rising. So C is the choice, sir. Question number 18, C is the right choice. Now we are on the question number 19. A gas is trapped inside a cylinder by a mobile piston. The length of the gas column is 20 centimeter and the pressure inside the cylinder is P. The piston is pulled out a distance of 30 centimeter so that the length of the gas column is now 50 centimeter. The temperature of the gas does not change. What is the new pressure of the gas? Remember one thing, because the gas is inside the cylinder and you know the volume of that gas will be the cross-sectional area multiply the length of the gas column. And when the length is 20 centimeter, it will be cross-sectional area multiplied 20 centimeter. That will be the volume. And when the length is 50 centimeter, the volume will be 50, when the cross-sectional area multiply 50 centimeter. Basic formula is the volume of the cylinder is the cross-sectional area multiply length of the cylinder. So because here the temperature is constant, so we can apply the formula P1 V1 is equals to the P2 V2. Okay, here it is written the temperature is constant. What is the new pressure of the gas? Okay, so let me show you. I have done this. So the P1 V1 equals to P2 V2. The P1 is P1 length and the cross-sectional area P2 L2 cross-sectional area. Cross-sectional area in both the sides is same. So it will be cancelled. So P1 L equals to P2 L. So P1 is suppose P. So the length for the first length is 20 centimeter. P2 is question and the second length is 50 centimeter. So the P2 will be equals to 20 divided by 50 into P. So it will be 2 by 5, which will be 0.4 P. 0.4 P. 0.4 P. So this is the choice. A. This is the solution. We think A is the right answer, sir. Question number 19, A is the right answer. Question number 20. Pot X and pot Y are both in a cool room. Pot X contains hot water below its boiling point. Pot Y is identical to the pot X but contains water that is kept boiling by a hot plate underneath it. So here you have just put that hot water in a cool room, so it will eventually cool down. In the Y, you have put a hot plate. So it is providing the heat and the water in it is boiling. What happens to the average kinetic energy? What happens to the average kinetic energy of the particles in the liquid water in the pot X and to the average kinetic energy of the particles in the liquid water in the pot Y? You see, because in the pot X, it has hot water and it's cooling down, so the average kinetic energy of its particles is basically decreasing. And in the pot Y, the water is kept boiling. So you are providing energy from the hot plate, and it's boiling. So when the boiling is taking place, the temperature do not change. So when the temperature do not change, that means that the kinetic energy will not change. Okay. So in the X, the kinetic energy of the liquid particles is decreasing, and the kinetic energy of liquid particles in the Y, it does not change. So I think B is the right answer, sir. I hope you understand. Question number 20, B is the choice. B is the choice. Okay, so we have question number 21. Solid metals are good thermal conductors. How closely packed are their particles, and do the metals contain free electrons? So, solid metals, obviously, the particles are close together and they also have free electrons. So, I think B is the choice. Question number 21, B is the right choice. Then we have question number 22. He says cotton wool is a good thermal insulator. It consists of many threads of cotton which are tangled together to make a material which can easily be pulled apart or compressed. The diagram shows the structure of the cotton wool. Why is cotton wool a good thermal insulator? The reason is that cotton wool traps air, which is a bad conductor of the heat. So the reason is it traps air and prevents convections. No. Uh, each thread is very thin. No. It has a large surface area because it is made of many threads. No. It has a low density because of the trapped air. It traps air and prevents convection. I think this can be the answer. I think question number 2. Why is cotton wool a good thermal insulator? The reason is trapped air and it prevents convection. So I think D is the choice. Question number 22, D is the choice. Question number 23. A metal kettle is heated on a grid above red hot glowing coal. What are the main thermal energy transfers through the bottom of the kettle and within the water? So through the kettle, because this is of metal, so there the conduction will take place, and in the water, what are the main thermal energy transfers? Okay, so in the water, the convection, with the help of convection, the energy is transferred. So through the kettle, conduction, and through the water, convection. I think C looks the best answer. Question number 23, C looks the best option, sir. Question number 23, C is the right option, sir. Okay, so here we have question number 24. Okay, so we have to. The diagram shows two waveforms. Which arrows shows the wavelength of a longitudinal wave? You see, this diagram here shows compressions and refractions. So this is a longitudinal wave. So the which arrow shows the wavelength? The wavelength will be from the end of one compression to the end of the consecutive compression, the next compression. Okay. So I think A is the best option. That is the wavelength. Okay. Question number 24, A is the answer, sir. Question number 24, A is the right answer. Okay, then we have a bell on a wall. Question 25. A bell on a wall outside a classroom rings. A student is standing at point X shown on the view from above. So they are taking from a top view. So a student is here. The bell is here. Here we have that. Here's that door. Here's that wall. But this student is able to hear this bell. Why? The door of the classroom. The door of the classroom is closed, and the student in the room at X hears the bell ring. The door is opened, and the sound heard by the student from the bell is louder. What causes the sound reaching the student to be louder? You see, here we have obstacles in the path of the sound waves. and on the edges of these obstacles, the sound waves are able to bend. This is called diffraction. Sound waves shows diffraction. That is the reason the sound waves are able to reach the student at the position X. So the reason is diffraction. What causes the students reaching the student? What causes the sound reaching the student to be louder? I think diffraction. 25A is the choice. So here we have, he says, a boy stands beside a girl in front of a large vertical plane mirror. They are equal distances from the mirror. As shown, the boy sees an image of the girl. Where is the girl's image? Okay, so here you have the boy, here you have the girl, this is the mirror. So you can draw a straight line from with the help of this from the girl, you will draw a straight line, and you will draw a straight line. Okay, this makes 90-degree angle with the mirror. Then uh, you can take a middle point between the boy and the girl. Approximately this will be C. From here you will draw a line here, then you will draw a normal here. Check how much is this angle of incidence. With the help of a protractor, draw angle of reflection. This angle of reflection should be equal to the angle of incidence. Then prolong this behind, and where that line intersect, here the boy will be able to see that the image of that girl. You will have to do this with the help of the protractor, with the pencil, with the straight edge. Do this on your hard paper, hard copy of your paper. And then you will be able to tell where the boy will be able to see the image of the girl. Just follow what I have said, and this will be the position A. So I think that the boy will be able to see the image of the girl at the position A. 26A is the choice. Question number 20, we have question number 27. He says light traveling in air is incident on a water surface. The refractive index of the water is 1.3 and the angle of refraction in the water is 40 degree. What is the angle of incidence in the air? So because the light is entering from a rare medium into the dense medium, so the refractive index will be n equals to sine I divided by sine r. I know the R value, so I will try to find out the I value. Very simple. And here you can see, so N is equals to sine I by sine R. So 1.3 equals to sine I divided by sine 40. So the sine I will be equals to 1.3 into sine 40, and I will be equals to sine inverse of 0.84, and that will be 57. So I think, let me show you the whole thing. Okay. So 57, so I think D is the choice. Question number 27, D is the choice. So here we have another question, and that question says, the diagram shows a ray of light passing through a triangular glass block. Which angle is the critical angle of the light in the glass? Critical angle is that angle of incidence in the glass or the dense medium for which the angle of refraction in the rare medium is of 90 degree. So that angle of incidence is this one. You can see this is the angle of incidence in the dense medium for which the angle of refraction in the rare medium is of how much? 90 degree. So this angle of incidence is called the angle of the critical angle. So D is the choice. Question number 28, D is the right choice, sir. Okay, so we have question number 25. He says a lens, 29, sorry. A lens is used to produce a magnified image as shown in the scale diagram. So here you have the object, here you have a convex lens, here the image is formed, it's a real image, it's a magnified image. Their question is, what is the linear magnification produced by the lens? You know, the formula for the linear magnification is very simple. Let me increase the size so you can understand this. It is the height of the image divided by the height of the object. You see, the height of the image is 1, 2, 3, 4, 4.5. The height of the image is 4.5. The height of the image is 4.5. The height of the object is 1.5. So it is the height of the image is 4.5 and the height of the object is 1.5. The linear magnification, the formula for the linear magnification is the height of the image divided by the height of the object. So let's see. Uh, Linear magnification is height of the image divided by the height of the object, 4.5 centimeter divided by 1.5 centimeter, and that will be 3. So the linear magnification is 3. The linear magnification is 3. So I think B is the choice. Question number 29. Question number 29, B is the right answer, sir. So we have question number 30. He says, ultraviolet radiation is a component of the electromagnetic spectrum. Which application uses ultraviolet radiation? UV light is used for sterilizing water. UV light is also used in tanning. So I think C is the right choice. It is used to kill germs. Question number 30, C. C. Question number 30, C is the right choice, sir. Question number 31. A student rubs different rods held in his hand. Which rod gains a large electrostatic charge? You see, by rubbing, you are able to charge those objects who are insulators. So when you rub two insulators with each other, you can produce charge on them. A polythene rod rubbed with a steel magnet, no. A polythene rod rubbed with a woolen tester, that is the best answer because both of them are insulators. An iron rod rubbed with a steel magnet, no, 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 no. An iron rod rubbed with a woolen tester, no. You are supposed to rub two insulators with each other. So B is the choice. Question number 31. B is the right choice, sir. Question number we have on the screen, question number 32. Two permanent magnets are placed inside, two permanent magnets are placed in side by side in four different arrangements. In which arrangement do the magnets repel each other? Magnets will repel each other uh, when the same poles will be facing each other. Sorry. Repel each other. When the same poles will be facing each other. So here, the same poles are facing each other, and here the same poles are facing each other. So here the magnets will repel each other. When the opposite poles are facing each other, they will be attracting. So in the second and the third case, the same poles are facing each other. So here the magnets will repel each other. So I think question number 32, C is the choice. So that is right. Okay. Question number 33. Which graph shows how the current changes when the voltage across a resistor of constant resistance is varied? The resistance is constant, so it will be a ohmic conductor. And the current voltage graph of an ohmic conductor should have a straight line graph with a positive gradient passing through the origin. So I think A must be the choice. Because for the ohmic conductors, the current and the voltage, they are directly proportional to each other. For two quantities which are directly proportional to each other, the graph must be a straight line passing through the origin. So question number 33, A is the choice. Question number 34. He says two identical resistors are connected first in series and then in parallel. The two resistors in series are connected to a power supply and the current is IS. The parallel combination is connected to the same power supply and the current supplied is IP. What is the ratio of the IS to the IP? Okay, so it's a little tricky question. So let me show you. Here we have. So when you have two identical resistors connected in series, so their equivalent resistors will be R plus R. That will be 2R. So the current will be the EMF of the battery divided by the equivalent resistors of the circuit. So it will be V divided by 2R. When you connect two identical resistors in parallel to each other, their equivalent resistance will be 1 by R equivalent equals to 1 by R plus 1 by R. So it will be 1 by R equivalent equals to 2 by R. So the R equivalent will be R by 2. The current in the parallel circuit will be the EMF of the battery divided by the equivalent resistance of the circuit. So it will be the V divided by R by 2. So it will become 2V divided by R. Now, if I will take the ratio of the current in the series circuit and the current in the parallel circuit, so it will be the V by 2R, 2V by R. So when you will bring this fraction upstairs, so it will flip. So V divided by 2R into the R divided by, so the R and the R will be cancelled and the V and the V will be cancelled. So your final answer will be 1 by 4, that is 0.25. So the ratio between these two currents will be 1 by 4, or you can say 0.25. So I think A is the choice. A is the choice. This is the answer. Question number 35. The output of an AC generator is connected to a lamp. The coil of the generator is rotated at a constant rate, which makes the lamp flash twice every second. The coil is then rotated at half the rate of rotation. What happens to the maximum brightness of the lamp and how many times does the lamp flash every second? Because you have made the rotational speed half, so what will be the effect? The EMF produced will become less. So the brightness of the lamp will decrease. So this is one thing which will happen. The brightness of the lamp will decrease because now the generator will be producing less EMF. Another thing will happen because now the coil is rotating slowly. So the AC current, its wave, its one cycle will be completed in a longer time. So now the lamp will flash less in 1 second. So I think once in a second. So the brightness will decrease and the lamp will be, because its time period will increase. So in 1 second, before it was switching on for 2 times, now I think it will switch on only 1 time. So I think 35A is the choice. 35A is the choice. A little tricky. Question number 36. He says that which device uses the magnetic effect of an electric current? The compass, fuse, no. Loudspeaker, yes, loudspeaker uses this. Magnifying glass, no. In the loudspeaker, we have a coil. In that coil, we pass the alternating current and it becomes electromagnet, and due to that, that coil moves, but it interacts with the magnetic field of a permanent magnet. So I think C is the best option, sir. Question number 36, C is the right answer, sir. So here we have question number 37, a big question. A wire is placed at right angle to a uniform magnetic field. There is a current in the wire and it experiences a force. Beam of alpha particles, beta particles, and neutrons are fired into the magnetic field in the same direction as the conventional current in the wire. Which beam experiences a force that is initially in the same direction as the force experienced by the current carrying wire? So, because in the wire we have conventional current, so the alpha particles, which are positively charged, they will experience the same, means in this, they will experience the force in the same direction as that wire experienced, because the alpha particles are positively charged. So they will also experience same direction of the force in that magnetic field. Beta particles will not experience that force. They will experience the force, but in opposite direction, the force which was experienced by the wire. Because the beta particles are electrons, they are negatively charged. Neutrons will experience no force because they are neutral. So I think B is the right option, sir. Let me reduce the size. He says tick means the beam experiences a force in the same direction, and the cross means beams does not experience a force in the same direction. So let me reduce the size of this question. This is question number 37. I think B is the option, sir. Question number 37, B is the right option, G. A little tricky and new question, sir. Style of the question is new. Question number 38. The diagram shows the trace produced on the screen of an oscilloscope due to an alternating voltage input. The time base, which means the scale on the x-axis, the time base on the oscilloscope is set at 4 millisecond per centimeter. So 1 centimeter here represents 4 milliseconds. What does the trace look like when the time base is set at 2 millisecond per second? 2 millisecond per centimeter. So here you can see the wave is completed in how many? 1, 2, 3, 4. 4 multiply 4, that is 16 milliseconds. So the time period of this wave is basically 16 milliseconds. So when you will set the time base at 2 milliseconds per centimeter, you have changed the scale. So now what will happen? Now 16 divided by 2, that is 8. So now the trace will be on 8 centimeters. A complete wave will be on 8 centimeters. The complete wave will be on the 8 centimeters. 1, 2, 3, 4. No. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. So I think C is the right answer. The amplitude should remain, and the amplitude here is 2, and the amplitude here is 2, the amplitude here is 2. Okay. So I think C is the best option to me, sir. It's a huge question. So I think C is the choice. I hope you understand. Question number 38, C is the choice. The same wave is shown in both the cases. First, that wave was shown on the CRO screen, and the time base, which means the scale on the x-axis, was that the 1 square on the x-axis represents 4 milliseconds. So that trace is given there, and I checked from there that to complete one wave, they have used 1, 2, 3, 4 squares. So that means 16 milliseconds. The time period of that wave is 16. Now they change the scale of the CRO. So now it is 2 milliseconds per centimeter. So the same time period, but the scale has changed. So divide 16 with 2, you get 8. So that trace will be on the 8 centimeter because the vertical scale has not changed. So the amplitude will still be the same. So C is the right answer, sir. Hopefully you understand. We think C is the choice. Question number 38, C is the right choice, sir. Okay. Now we are going to the question number 39. He says the half-life of a radioactive isotope is 2.5 minutes. This isotope is the only radioactive isotope in a radioactive sample. Between time t equals to 0 and time t equals to 7.5 minutes, the mass of this isotope in the sample decreases by 70 microgram. What is the mass of the isotope at the time t equals to 0? Very tricky question. So he has given you 70 microgram, which means this much mass has decreased. A very tricky question. The half-life is 2.5 minutes. So total 7.5 minutes have passed. So 0 to 2.5, 2.5 to 5, 5 to 7.5. So we think that 3 half-lives have passed. So when 3 half-lives have passed, the remaining will be n naught by 8. Okay. So how many of these atoms have decreased? That's a very tricky question. How many have decreased? That will be the initial count minus the present count. So n naught minus n naught by 8. So now the left, how many have decreased? They have given us that will be 70 microgram. And when you solve this fraction, you will be left with the 7 and naught by 8. So n naught will be 70 multiply 8 divided by 7. So that will be 80 microgram. A very tricky thing, a brand new type of question. 39. I hope you understand. You see, whenever we solve these questions of the half-life, from this grid, the value we get is the amount of the sample which has not yet decayed. And the amount he gave you, 70 micrograms, that is the amount which has decreased. So the amount decreased will be the initial count and not minus the present count. After 3 half-lives, the present count will be n naught divided by 8. A tricky question. So we think 80 microgram. 80 microgram. This is our choice. Question number 39B is the choice. That is right. Little tricky question. Question number 40. When observed on the Earth, the redshift of the light from the galaxy X is smaller than the redshift of the light from the galaxy Y. Which galaxy is closer to the Earth and which galaxy is receding from the Earth faster? The galaxy who has smaller redshift is relatively nearer, closer to the Earth, who has the less redshift. And the galaxy who has larger or more redshift is further away and is receding at a faster rate. And that is why. You see, the redshift idea is that the object from which the light is coming, if it is moving away from the observer, the light from that, when reaches the observer, its frequency decreases because that the source of the light is moving away from the observer and its wavelength decreases. This is called the red shift. So the light, the sources whose light has more redshift, that means they are further away from the observer. So the one which is closer to the Earth will have less redshift, and the one who is going away will have larger redshift. So B is the choice. B is the right choice, sir. So, my dear students, today we have done, I think, October and November 2023 1-2 paper. I have tried to explain you the concepts. Hopefully, this video will help you. If you find this video useful, if you find this video helpful to you, if it helps you to prepare your exam, please like this video, please subscribe my channel, please share this video onto your Facebook, onto your Twitter account, onto your Instagram, onto your TikTok accounts, into your WhatsApp groups, so that this video can reach all those students who are seeking help in preparing their exams on the YouTube. Thank you very much. Have a good day. God bless you all.